Yeah, very good morning to all. I'm sharing the QR code. Give the attendance. Then we will start. Okay. So I think everybody has given the attendance. Then we can start. So today I'll start module 3. And wait. Instrument. It is instrument for generation. So wait. The module is instrument for generation and analysis of waveform. Okay, so new module, new topics. I don't think these topics you have learned before. So first topic of this chapter is sine wave generator. Okay, so we will start with that. Sine, first topic, wave generator. So from the word sine wave generator, what idea you can have? What kind of circuit is this? From the term itself, you can get an idea. So can you share with me what is the idea you are getting from the term? Any idea? Sine wave generator. This is the first device that we will learn here in this chapter. Can you tell me what idea you can get from the term sine wave generator? Please share your thoughts. Anyone? Who are there? 11 students are there. Who are there? Monica, Saubhagya, Shikha.
Yes, ma'am.
Bolo. What are the idea you are getting? Sine wave generator. क्या हो सकता है? I mean, any guess, any guess. You don't have to be correct for what.
Ma'am, a circuit which is used to generate sine wave.
Yes, correct. The circuit which is used to generate sine wave, a very simple definition if you say, then that is the sine wave generator. Okay, so this is a kind of, we can get waveforms. With the help of this generator, we can obtain sine wave waveforms, and this waveform can be observed in various AC powers mainly. Okay, so what are the things that you have to learn? Very basic things you have to go through about this sine wave generator. Let me tell you. So after, there are many devices you will learn here in case of in this chapter. First is sine wave generator, then is frequency synthesized signal generator. Okay, then is frequency divider generator. Just a second. Okay, now don't think that sine wave generator, they directly give you the sine wave, not at all. This circuit generates a sine wave by first generating a square wave, okay, at required frequency with amplifiers, and then oscillators are used somehow to maintain the thing. So sine wave generator mainly we do using op-amp. Op-amp is a very important thing. So op-amp you must have learned in your basic electronics before. So mainly sine wave generator. This is we use the op-amp. The sine wave generator circuit using op-amp, that we will mainly concentrate. Okay. Just a second. Now, using op-amp, I have told you. So basic things is that it is mainly observed in AC power. Okay, AC power is the main thing. So device is something, if you see in your lab, just like the power supply devices you have seen, it looks like just like that. Okay, working principle, if you come to the sine wave generator, it generates sine wave. The frequency of this generator will range from, this you keep in your mind, it will be 1 hertz. Let me tell you, it will be 1 hertz to 800 hertz. Okay, so this is the frequency range of the sine wave generator, and the sine waves amplitude will be changed. Okay, so you can notice this nature or this kind of device mainly in lab. Now the features, there are some of the features which a sine wave generator have, and out of that, first of all, we will discuss the sine wave using op-amp. Let me circuit I have to draw, I'll show you. Wait. Okay, what I'm getting with transistor. Just a second. Yes, with op-amp. With op-amp. Just a second, okay. Wait. This picture I can't draw. I have to show you. If I draw, it will take much more time. Let me show you the picture. Okay. Now I will share a screen with you. Just see whether it's visible or not. Is the screen visible?
Yes, ma'am.
Okay. So this is the circuit with the op-amp. You can see two op-amps are connected. So mainly we will discuss with this, because if I'm going to draw this, it will take a lot of time. Now sine wave generator circuit using a op-amp is this picture. A sine wave signal is used along with some, you can say, arbitrary frequency first, is used for to design various circuits. Okay, mainly that is the word. So this kind of circuit you can see here, which I'm showing here, it is having two op-amp. Okay, that means we sometimes call it as dual op-amp. The word comes dual op-amp if you use two op-amp. Okay, so resistors and capacitors are there that you can see here. So the following this circuit, it is producing a sine wave by generating a square wave first, I told you. Directly a sine wave generator doesn't produce the sine wave directly. First of all, it produces square wave. So that is done here with a necessary frequency using this amplifier A1. Okay, so after the output of the A1 amplifier is a square wave. And then the output of the A2 amplifier becomes the sine wave. So connection of this amplifier can be done like a stable oscillator, and the frequency of this can be determined through the resistor R1. You can see this R1 and the capacitor C1. Okay. Now you can see here two poles that is in the amplifier A2. What will happen before taking the output of the A1? That means what? What is the input of A2? Output of A1. Output of A1 is the input of A2. So we need to what? Filter the output. We need to filter the output of the square wave signal that is from the amplifier A1. Okay. So this filter cutoff frequency is equivalent to the frequency of the square wave from the amplifier A1. So whatever output we are getting from the A1, that needs to be filtered. Whether it's a square wave signal, anything that needs to be filtered, and then it becomes the input of the A2 op-amp. So square wave signal is made up of very basic frequency, and abnormal harmonics definitely are there in the basic frequency. So most of the harmonic frequencies, they are removed by using filter, and basic frequencies somehow remain in the output of the amplifier. They won't harm so much, so we let it remain. Now the square wave signal basic frequency component that is here, that is somehow 1.27 times, okay, the times the square wave signal's peak amplitude. So output of the sine wave, what we are getting here, that will be around 87% of the square wave signal. So don't you think that whatever output, square wave output we are getting from the A1, exactly 100% of the square wave output are converted into sine wave. No, it doesn't happen like that. 87% of the square wave signal gets converted to the sine wave amplitude. Okay. So peak of this wave actually depend upon the supply voltage of the amplifier, whatever you are using. And this peak of the sine of the square wave that will change according to the supply of the amplifier. So in this particular circuit, you can see here the frequency, if it's specified along, there are C1, then there is C2, where is C2? This is C2, this is C3, okay? And again, there is R1, there is R2, this is R3, and there is R5, there is R4, where is R? This is R4. Okay, so here the resistor values are 1K ohm. All the resistor values are 1K ohm. And this is actually done to minimize the errors during the operation of actual frequency when compared with the operation of the calculated frequency. Okay, so the equations I will write now. The necessary sine wave frequency is capital F they are considering. Okay, this is the sine wave frequency. So capacitor C1 value you can select randomly. This C1, this value you can select randomly, and other value components are calculated. So how it appears, let me show you. I am removing everything. Okay, how that is what they are doing. They are taking C1 equal to C2. Okay, C1 is equal to C2 means whatever the value of C1 you will take, that can be equal to C2, and whatever R1 we will take, that is somehow that will be 87. I mean, R1 is here 1 kilo ohm. Okay, and the calculated thing that you can take as 1 by 2f. 1 by 2f. 2f I told you that is the sine wave frequency. Okay, so this thing actually happens here. So not so much equation wise it is required in your case. So just get an overall idea that how the sine wave generator works. That will help you. Okay, only that thing will. Now, second thing is that sometimes this kind of sine wave we have done here with op-amp. Okay, you can down that with Arduino. You can done that with a transistor. So that thing are not in your syllabus. You're only having sine wave generator. So that can be that is the most easiest way to understand is using op-amp. Okay. What are the functions now? Generating, another thing is that in sine wave generator you can have another type, that is DAC. DAC sine wave means digital to analog converter sine wave generator. So sometimes in this case, sometimes this conversion during digital to analog conversion, we require sine wave generator. So if you find out the application of sine wave generator, this is one of them, DAC sine wave generator. Okay, so just try to learn the basic principle that if you are asked to write sine wave generator about, they will relate to direct question that describe sine wave generator. Okay, that's it. So just you take this diagram and just somehow explain this, that we are getting this kind of resistance, capacitors are here, we are getting some output from the amplifier A1, and then the output of the A2 is the sine wave output. Okay, that will help you. That will do. Nothing much more is required. Okay, now I will shift to the next topic. That is, wait, stop sharing here. Our next topic will be frequency synthesized signal generator. Okay, I'm again sharing a PPT with you. So have a look. I think this is visible to everyone. So see here written about frequency synthesized generator. So this is also a new topic, frequency synthesized generator. Now, this chapter is all about different kind of this generating device. Okay, So it is also called a signal generator. Now, frequency synthesized signal generator, this is basically it allow to generate a signal that have a variable frequency over a wide range. Okay, so frequency actually matters. So main thing is that variable frequency, to generate a signal. So it will generate a signal. This frequency synthesis generator will generate a signal. It will generate a signal that will be having a variable frequency, okay, over a wide range. So the need to generate a signal with a frequency that is different from the reference signal is very important, or you can say that helps in signal transmission. So see in the PPT what is written. Frequency synthesizers are basically RF. RF, what is RF? What is RF? RF you have learned many where. What is the full form of RF?
Radio frequency.
Yes, yes. And what does it do? What are the, I mean, what is the importance of RF signal? Can you tell me? What is the importance of RF signal? Why they are so widely used, and what is the importance? Basically, what is the RF signal? You have any idea? RF signals का एक बहुत ही live example बताओ. I mean, live example in the sense, I want to say that a very practical example that every day it's with us, and we use it every day. Can you tell me?
Ma'am, TV.
Yes, very good, Rajkumar. TV, video, televisions, FM radios, everywhere RF signals are used. So basically, if you come to the word RF signal, it is an electromagnetic wave that used in communication purpose to transport the information from air through air from one point to another. Okay, so RF signals are so important in our day-to-day life. And the most live examples or practical examples are musics. Then FM रेडियो में हम लोग म्यूजिक सुनते हैं, बहुत कुछ सुनते हैं ना FM रेडियो में. Then televisions, everything. Okay, and and what is the frequency of RF signal? Can you tell me what is the frequency of RF signal? Do you have any idea? Under which frequency? What is the range of frequency? Just tell me the range. रेंज बता सकते हो? What is the range?
मैम शायद गीगाहर्ट्ज में आता है.
हाँ, exactly. From 20 kilohertz to 300 gigahertz. That is why ना इतना ज्यादा इसका रेंज है RF सिग्नल का. So much wide range. That is why it is so much used. मतलब मैं यहाँ बैठी हूँ, I can listen to the radio, जो भी जहाँ पे भी मतलब रेडियो FM रेडियो स्टेशंस है, वहां से लेके लोग दूर दूर तक आवाज सुन पाते हैं. कैसे? This is the way, है ना? Something 300 gigahertz. So it's a variable, a very wide range of frequencies. So here in case of frequency synthesizer, mainly the RF signal is the basically source with the variable in output frequencies. So see here frequencies variable which are directly derived and generated from a precise reference frequency. So mind it, though the frequency here we are taking variable at the output, but the reference frequency is somehow, there was a reference frequency, means the basic frequency from which they have derived the variable output frequency. So the ideal output signal is a single spectrum line with no other unwanted frequencies. Ideal output signal is ideal. Okay, we can't apply it in a very practical situation. So it's written here, see, this can't be realized in practice. So all the RF signals have so spectral purity. So this purity actually only valid, or you can say only satisfied in case of ideal output signal, which is not possible. So actually what happened in this kind of combinations, harmonics are removed. So but in generally whatever generations are done, signal generation, their harmonics are present. Okay. Now you have to use filter to remove the harmonics. That's a different case. So everywhere filters are used. So if we say in any signal there is no harmonics, then it becomes a very ideal thing. So ideal thing actually does not exist. Okay. Now let us move to the next slide of this PPT. My next slide, this is the frequency signal synthesized signal generator. This is how it looks. So in measurement instrumentation lab, sometimes if you have experiment on this particular device, then only this kind of device are kept in the lab for your experiment purpose. Okay, so I haven't seen frequency synthesized signal generator in my lab when I did my BTech and instrumentation lab. I haven't seen that. So this thing is very optional. This kind of device, they are mainly we use CRO. Mainly we CRO. That's a all-purpose solve device, and these are very optional device. So some labs they keep this device, some labs they don't keep. Okay. So this is the picture, and there are many buttons you can see here. There are all the probes connected. So all these probes have their own function. Many buttons are there. So just like a CRO, but the screen you can see it doesn't show any. There are some numbers are shown. So with any device, when you want to see this kind of frequency synthesized signal, you will connect the device. This kind of device. Okay. Now there are some methods of frequency synthesis for the first method is indirect method, second is direct synthesis. Now about phase lock loop, this term you have heard before, I think, because phase lock loop is a very famous term. Phase lock loop, this thing in which chapter in basic electronics there was, or in analog digital electronics, not basic digital electronics, you have this a separate topic on phase lock loop. So we mainly call it as PLL something it is said in short form. So in indirect method, you can say the components of indirect method, what are they? One is VCO, that is a voltage controlled oscillator. Okay. Second is what? Second is programmable divider, phase detector, phase reference, loop filter. So these are the components which we require in indirect method. Now this frequency synthesizer generator is also called RF frequency synthesizer. Okay, if RF frequency, it is most widely used, and sometimes it is also named like that, because I told you RF signals are the source here. So in that case, if you come to if I say that the picture how it looks like, the basic digital, I mean frequency synthesizer block diagram, how it looks very simple. Let me show you. The basic is there will be a reference. Okay, there will be a phase detector. This is the reference. Okay, this is the reference. This is the phase detector. And then comes the programmable divider. It's written here, na? Programmable divider. This is the programmable divider. Programmable divider. Okay. Then comes voltage controlled oscillator. In short form, I'm writing VCO. In short form, I'm writing VCO. And here, there is the output. We are getting here output. And loop filter is connected between VCO and phase detector. So it will be connected like this. Okay. So this is my loop filter. So see, all the components are I have connected here accordingly to their functions. Okay. So the arrows, somewhere I have done wrong arrow. Wait. यहाँ पे जो होगा, it will be just like this. यहाँ पे. This arrow will be like this. So you can see here, and divider control is just at the top of the programmable divider here. Okay, there is a yes called divider control actually. Okay, so this is the main components which I told you that the indirect method we require the main components. These are this is the actually, I mean, the outlook of this thing, that how they are connected. Okay. So reference, then phase detector, then programmable divider, then VCO, and the output and the VCO and phase detector, there is a loop filter connected. Output we are getting like this. Now let me move to the next slide. We have to discuss about VCO here. Now VCO, I have told you that what is VCO? It is the voltage source oscillator, right? So say indirect frequency synthesis is mainly based around phase lock loop, which I told you, PLL, okay, PLL, that is phase lock loop. So here the output signal is generated indirectly. In other words, you can say that the final signal which is generated by an oscillator is controlled by other signal. Okay, so in this way the signal are used here, and they are given why it is called indirect method. Even I mean, just now the picture which I have drawn, let me show you. In this picture you can see here that that the connections which is made, there is a loop filter connected downward direction, means it shows that the output signal is generated indirectly. Okay, and it's totally depend upon the PLL, that is the phase locked loop. So see here about the VCO, what they have written. Now you have to understand each and every component. So VCO is the source of output frequency. It has the ability to tune electronically, usually by applying a variable voltage. So oscillators are used as a component here, and some oscillators, it's written here, see, they are tuned using a current, especially in high frequency. But for general discussion, indirect synthesizer, the signal source will be considered as voltage control device. So voltage control oscillator means definitely you have to control the voltage. Okay, whatever you are obtaining, you have to control the voltage. Then comes programmable divider. What is this? You have seen that just now, the diagram which I showed you is connected in between. It's a logic element that divides the frequency of the VCO by an integer that can enter via programmable switches, a microprocessor, or other methods. So definitely this divider is a logic element that divides the frequency of VCO by an integer. Okay, so a bit programmable divider definitely depends upon the switches, that may be a microprocessor, anything or any other method. Phase detector, it provides analog output that is a function of the phase angle between two input, which in the case of a frequency synthesizer is the reference source and the output of the programmable divider. So let me show you the previous diagram, which this one diagram. I think you remember here that this is the programmable divider, and both the you can see the arrow reference का जो output है, that is going into phase detector, और programmable divider का भी जो output है, that is also going into the phase detector. So what it will provide analog output. Okay, that is a function of the phase angle between the two inputs. That means which are the two inputs? The two inputs are the inputs of a reference and the reference source and the output of the programmable divider. Okay, these two are the inputs of the phase detector. So this is the thing. Okay, next we can move on to the next component, that is reference sources. So reference source, it's a very accurate, stable frequency source. And what type of reference source we use? It's written clearly. We use quartz crystal oscillator mainly. So keep this in your mind, quartz crystal oscillator. Accuracy of entire synthesizer, it depends upon the accuracy of the reference source. So the crystal oscillator, what has been used here, it has a frequency range of 1 to 10 megahertz. You can see here 1 to 10 mH is written here, and the frequency is divided down using digital counters to provide necessary log and reference frequencies for the synthesizer. So this is important, that what kind of source you are using and what is the range of that source. So you have to remember the range also. Now come to loop filter. Loop filter, you can see the connection correctly here. It is connected between the VCO and the phase detector. So you can also call it as analog filter, and it's required to assure, it's written here in the PPT you see here, to assure stable and noise-free operation of the synthesizer. So that the synthesizer work properly, and it gives the noise-free operation. So we use here loop filter. Okay. Now we can move to the next slide. Next is working of PLL. This is important. See, programmable divider. Here it comes the importance of PLL. What is PLL? Phase locked loop, right? So the programmable divider, it divides the frequency of the VCO by N. That means if my frequency is FV, suppose, for say if my frequency is FV, then it will be divided by N, or FR, FP, FR, what are this? It's written clearly here, you can see. FP is the desired frequency of the VCO, okay? And FR is the reference frequency that is applied to the phase detector. So two frequencies we have, and N is the integer that is entering into the programmable divider, okay? So which I discussed already with you, the phase detector, in the phase detector. Now, whatever output we will get from the programmable divider, that is fed to the phase detector. You can see here the arrow sign. The arrow sign, see here the arrow sign. That means the output of the programmable divider is fed to the phase detector. That becomes the input of the phase detector. Okay. So, and compared to the phase of the reference frequency. So, what is the reference frequency that is applied to the phase detector? And what is the desired frequency? These two are compared to understand. Now, see here, another thing what is written, I'm rubbing this portion totally, or I'll keep this. So let me read it out. It's something written that depending upon the output of the phase detector, and in combination with the VCO. Okay, so you can see here whatever output we are getting from the VCO, that is not a direct output. I mean, programmable divider giving its output to phase detector, then something output is coming, then through the loop filter is going to VCO, right? It is not a direct path. It is something around path. Okay, so it's written the importance of VCO. So VCO actually plays a very important role. It causes the frequency to be modulated, and the output of the VCO, it is used from precision measurements. Okay, so precise output we are getting after so many things, so many there are variation of phases, then frequencies, then n times of reference frequency you are taking, n is the integer, everything is going on. So, and one more thing, loop filter, which is doing a work, which I told you, it's connected between phase and VCO, so that the frequency which are changes going on so much fluctuations, they are get smoothed, and definitely whatever output we are getting, that will be, in that case the frequency modulation is reduced. Okay, so this picture is very important, keep in your mind, otherwise it's difficult to understand. So see, another picture has been shown here, just like mine, which I have drawn for you. This is the VCO, this is the divider, phase detector, reference frequency source, loop filter. So you can also refer this picture for your understanding purpose. Okay, so this picture is also good. So this is a block diagram of PLL. We are discussing about indirect method. Don't forget, we have not gone to direct method. We are only discussing about indirect method. Now, definitely, this method has some disadvantages. What are those? See, it's written here. It's not capable of removing sideband energy, and then loop filters affect the frequency, slewing, the characteristic something, it depends upon the harmonics, okay, and change in frequency of signal generator, with large amount of time, that is also being for the change, it can be long. So when it is necessary to change the frequency, so change in frequency, you're taking a lot of time. That is also some of the disadvantages of this method. So in my next class, I will start with the direct method of this particular topic, that is frequency synthesized, yes, direct synthesis method, which I have not started today. So in my next class, that is on maybe Monday, I will start with the direct synthesis method. Okay. So I think everybody has given the attendance. So thank you so much for attending.